with sort of water, you'll get very little rain. That's what you see. On the other side, a few cloud droplets with a lot of water on each one, with lots of rain. So again. Now, I can compare this to my coworker. She made the same plot using the rest of the clouds from the SOLAS database, just some measurements. And this is the same plot as before, just expanded the axes so that it matches with this. So, obviously they don't line up. Two reasons for this could be that my fit was made using about 40,000 points. Hers was made using 8 points. So there could be some errors in that. Another reason would be the conversion between the amount of cloud droplets and rain in the model, and that can be tweaked. So that would be something to work on, because you can change how the rain comes from the cloud droplets. So for future work, there's more clouds in the SOLAS database to recreate. There's another database known as NAIR, which has like 20 other clouds, so lots of work to do. And an audacious goal would be to couple the aerosol and cloud microphysics modules within the same. Thank you.
Yeah, in your simulated model, you put the temperature constant.
Yeah.
And how does it affect your results? Because actually temperature is constant during 4 days.
Oh, right, yeah. The reason why it was simulated for 4 days was it sort of like recreates this cloud sort of constantly. I'm not trying to predict what happened after the cloud was made. So 4 days just gives you more data points, more sort of time steps. And so the sea surface temperature, when they took the measurements, they only took measurements for about a half hour. So that's why I kept it constant. Does that make sense?
Yeah.
Okay, and the reason, if I made it lower, almost fog forms at the bottom since there's colder. So that would happen if I changed. If I made the sea surface temperature colder, it would just sort of lower the cloud height.
I'd like to know what technique you used to measure the droplet size.
This wasn't, I sort of just got this data, but
yeah.
We have this, I think, this is an example of one. Well, this is a picture of the device used to measure the aerosol size distribution. And they sort of have like lasers going, and they can see like how they diffract as these particles go through when they sort of divide them up in size bands. I think for the precipitation, they sort of just have this big sort of open grid